You can.
This meeting is being recorded.
Good afternoon, good morning, everyone. Welcome to episode 3 of Solar United's Coffee Chat. We're super excited to have an amazing guest with us today, but before we dive too far into what we'll be discussing in today's session, just want to go ahead and give a special shout out to our supporters of Solar United. These logos that you see on your screen right now help us put together these type of sessions. The session will be recorded, so you can get the benefit of watching it at a later date if you can't stay with us all the way today. But yes, if you want to see your logo up here as well, feel free to give me an email or something like that, or if you have something special that you want to discuss in a session, again, you could reach out to me at Solar United. My information's on the solar-united.org website. So I'd like to thank everybody for joining us. And right now I'd like to turn things over to today's host, Heinz Olsenbrink, who helps put these sessions together with us. So Heinz, I'm just going to stop sharing my screen and I'm going to invite you to take over at this point. Thank you.
Okay, thank you, Brian, for this nice introduction. And just to myself, I'm in photovoltaics since 1982, somewhat guilty for all these qualification tests which are today in place for solar cells. I had my own experiences with vehicle integrated PV and joining the first Swiss solar boat races in 1992. And since then, I'm very much interested in very particular use of solar cells. After I retired, I became also pilot. And so this leads me today to our today's guest, Raphaël Domjan. He's a Swiss explorer, I would say it, and adventurer even though his solar projects are not really only adventure, but very well designed and prepared undertakings to make the use of photovoltaics known to many people which are excited about this particular use. Now, today, Raphaël will certainly tell us something about his latest undertaking, which is the SolarStratos project, solar-powered plane, which will reach the stratosphere. But maybe, Raphaël, you will tell us also something about your previous project, in particular, a solar crossing of the Atlantic or a solar circumnavigation of the planet, even though in very northerly latitude. So, Raphaël, it's your turn. We will later just stream the questions of the audience which come up. We will put you some questions, make it as lively as possible. To the audience, I need to say it's a coffee chat, so keep your coffee ready. Raphaël, it's your floor.
Thank you, Heinz. Thank you, Brian. So first of all, I am very happy to be with you. I will just share with you my first project. I don't know if you know me, but I will just share with you my first project. Who actually, it's almost 10 years that we finalized this first renewable powered by solar energy. For me, it was really an amazing adventure. And I have just a short movie. I will try to show you this short movie about PlanetSolar. So this was my first adventure. And after the boat, now we are trying to reach the stratosphere with a solar aircraft. This is our new adventure, and I have also a short movie. Heinz, the movie was okay?
The movie was perfectly visible. Yeah? Very good.
Super.
Thanks to our technical help.
Yeah, thanks for the technique. And I will show you the movie of SolarStratos now. So
a human dream powered by solar energy to the edge of space.
On est les premiers à construire un avion solaire biplace capable d'emmener un homme dans la stratosphère. Et lorsque tu es premier, il faut tracer le chemin, il faut ouvrir les portes. Finalement, la difficulté, c'est de réunir tous ces besoins pour réussir un tel projet. Des besoins techniques, financiers, humains.
Thank you very much, Raphael, for this. I think that was the best possible introduction in our chat today, which we always keep very. We receive a lot of questions to you, and I want also to use this occasion just to make one introductory question. Probably many people had seen and witnessed the round the world flight of Solar Impulse, also a plane from Switzerland. Now you have with SolarStratos another challenge. Instead of going as far as possible, you want to go as high as possible. And what does it mean for you as a pilot, as a particular challenge? We know that Solar Impulse, the major challenge was to stay awake so long. Now going to stratosphere, you will have other challenges.
Yes, of course. You know, first of all, you know, my goal for me is to try to protect our climate. This is really what I try to do by not telling the people what they have to do, but to show what we can do, mainly in my case with solar energy. And you know, I fly since I am 15 years old. I start to fly with a glider when I was 15. So for me, it's like you know, the Icarus flight. It's like a dream for me to go as the highest as possible. And to do this with the power of the sun is something that is very romantic for me. That's the start of this project. Of course, with this project, with PlanetSolar, we did something that every day you have boats that they are using fossil fuel, that they're doing this type of, you know, they go around the world. This is totally not new, but we did this with solar energy. With SolarStratos is to do something that is not possible to do with fossil fuel. You know, it's not possible to go that high with a fossil fuel engine because you need oxygen for the engine. So the efficiency of the engine is decreasing with the altitude. With an electric engine and with a solar aircraft, we get more energy from the sun, and the electric engine will keep this efficiency. So this is really something to do that we want to go one step further than what we can achieve with fossil fuel in order to demonstrate the power of solar energy and solar cells.
Thank you very much. I hear also, and I think we should give this opportunity to Bernhard, who is joining, who was also building of a plane, which he also was intending to convert to solar. Where was the problem, Bernhard? Bernhard? Bernhard Krause is there. Yeah,
no,
okay,
there is a mistake in the names and addresses. I'm sorry. Somebody is using my name in the chat.
Ah, okay. Okay.
Go,
Oh,
please.
So you have been hijacked.
Yeah, we've been hacked, I
maybe.
think.
So please go ahead.
I was actually impressed, Bernard. I didn't realize that you actually flew as well and made airplanes.
No, I'm more the person who is on or in the water. So the catamaran would be more interesting for me.
Great.
Okay.
Antonin, have your particular questions, I think, more technically or more general?
Yes, so Raphaël, for me it's really impressive. So with CSEM we are working with SolarStratos project all together to implement the PV, and maybe it's more maybe not so technical, because maybe technical question will be too deep in the detail, but more about how do you see the future about commercial flight, maybe electrical and then solar flight at the commercial level. Maybe this, Raphaël, what do you see?
Well, I think that really, if we are thinking about the commercial of aircraft and for aeronautic use, I think that will be more electric, hydrogen. Solar will still, I think we will use in some typical or very specific need solar cells, but it's really difficult to put this on the wings today. Also for the maintenance, how to know if you go, as an example, into the wind. That's, as you know, Antonin, at the moment, if you go to the wind with SolarStratos, I think it's the end of the plane. So I don't see today that the change will be on solar aircraft, but more on electric aircraft. And for some very specific application, maybe we will be able to use solar cells, but more to keep maybe some system on, I think it will be more like this than really the supplying of the power of the aircraft for the propulsion.
Thank you, Raphaël. So that means you drop back the ball to CSEM side, saying that we need a bit more development to implement solar cell on a solar airplane, which I think you're right. Today we are at really the beginning of this. We see that today for electrical vehicle, like on the road, it starts to be commercially available, and for sure electrical and solar plane need a few years more development. So we are here to do that and to help you, Raphaël, for sure.
But it's a little bit the story, if you think about the car, that in Switzerland we have almost 2,000 solar cars before the end of the 90s. Then now we have almost, I think there is no one solar car that is really running in Switzerland, but it's coming back. Now we have electric car, of course, but solar is coming back. I think it will be the same for both. I think it will. For both it will be different. The solar boat, they are really coming on the market now, but for aircraft, I think it will be like this. We will go to electric in a commercial way, and then in 10 years or 15 years, we will come back with some solar aircraft.
Yes, thank you.
Do you think that for commercial electric planes, which are everywhere in development, and I think they're very good results so far. I've seen models from Airbus Industries, but also from other regional airliner manufacturing. Could it play the role a little bit like we see in vehicle integrated PV for cars, that at least some percentage can be fulfilled. I'm thinking there in particular of the development of this pipistrelle electric plane, which is designed for flight schools. And I think Switzerland is the first country which allows a license as an electric pilot, where between flight lessons, or if the day is not fully covered as lessons, you get a considerable charge from the wings.
Yeah, I know quite well this aircraft. I fly this aircraft also, and we did a nice trip last year from Lausanne to Aix-en-Provence. I bring the Prince Albert II of Monaco. That's the first flight on, in an electric aircraft of a head of state. This is a very good example. At the moment, this aircraft, it's fully electric. And now they are thinking maybe to put some solar cell on this aircraft. But of course, when you fly, you use so much power with the electric engine and with these small wings. When you fly, you will get maybe 5 minutes more of flight. But of course, the weight is more important, and the complexity of the aircraft just for 5%. Because of course, when you are not flying, this type of aircraft, they are in the hangar, on the shadow of the hangar, you know. So it's why at the moment they are thinking to have this option. When you will buy a pipistrelle Vélis, if you want to have the solar cells, that will be possible, but it's maybe 2-3 minutes more of flight, nothing more, you know. And when you have put the plane into the hangar, you have no light. So maybe we'll have to change the hangar. So they have now some project that the hangar will be, the roof of the hangar will be able to carry the light inside of the hangar, you know. So we have to change the infrastructure of the hangar. So it's a big change, but I think it's coming, and we will see what will come. I am very anxious to see how it will go.
Oh, sorry. Go ahead, Nabi.
Thank you. Thank you. Well, first of all, I was really impressed by the video. It's very nice, and it shows really very interesting things. And the target is great because yesterday, as it has been said, we saw a solar impulse that's made around the globe trip that shows the long distance that we can we can go over with using the solar energy. Today, we're going to go up and to overpass the atmosphere, which is also another, I would say, milestone of achievement and what we can do for the solar. One of the things that I see in all these developments, they are extremely beneficial, and they will be extremely beneficial for what we expect in the common life for the daily, I would say, usage. Like for instance now, and one of the key points, I guess, for SolarStratos project is the weight of the panels, and how are you going to design that? And this will have automatically, I would say, once it's well developed, when it's technology approved, it will have for sure a huge impact to be implemented in other transportation, which are much more domestic and for common people, like for instance, cars, even I would say tricycle cars or train, whatever. And this is an extremely, extremely important point, that such project that sounds some times ago, something like a science fiction, if we spoke some years ago about a plane that's running and making a round trip of the globe just powered by solar, we're saying this can't be, it's impossible. But it was proven, and thanks to all the team of Bertrand Picard. Now another team, Swiss again, and I'm very proud and happy to see that something is going in the way to develop something that will be beneficial for other industries and other products. And this is extremely, extremely very important. In terms, one of the points that has been mentioned regarding how the modules will behave outside the atmosphere, where we have the satellites. They have been operated since many years successfully without any problem. I never heard, indeed, any failure happened because of the solar panels. Of course, that's the quality of the solar panels are something which is quite high level, but we use just a normal backsheet, the Tedlar backsheet that we use on it. We use some high efficiency cell, which are maybe 3.5, but all the other raw materials are the same materials that we use commonly on the standard modules. So I think that such development is extremely important, and is going to be extremely beneficial for other type of products and other applications. It's going to open indeed a new era of development and products. So this is the comment that I want to make. I don't know if Raphaël, you want to add about the ultralight modules, something about that, the modules that you are using, or these kind of things.
Yes. So, you know, I am not an expert like all of you, you know, about really the technology. I am more someone that is using these technologies, but I can see how it's changing, how fast it's changing. If I think about PlanetSolar, my boat, the weight of one module was a little bit less than 5 kilograms for 1 square meters, and the efficiency was about 20%. And now with SolarStratos, we are less than 1 kilo, and we are at almost 24%. So it's about 20% more of efficiency relative and much lighter. If we think about PlanetSolar, we did this trip at 6 knots. With the technology of today, I am sure that we can do almost 10 knots. So already much faster than what we did, and also the cost much below of what we did in 2008 when we started to build this boat. So the technology is going so fast, the cost is changing so fast. I am very optimistic to see, and sometimes I am thinking, okay, what we will get in 10 years from now, because now I think the speed of the change is just much more than what we had 10 years ago.
I'd just like to say something to the fact of going back to the commercialization of the project and the technology. Myself personally, I'm afraid of heights. So for me to go into an airplane is sometimes challenging, but then at the same time, over the course of my career, I've flown over 4 million miles just on Delta Airlines alone. So I guess getting into an airplane is not as difficult as it could be for other people. But then at the same time, you know, when we start to look at what these billionaires are doing right now, like Richard Branson and Jeff Bezos, you know, they're more now looking at the opportunity to go into space, and you're getting to the point where you're touching space. From maybe as an intermediate step, could you foresee that there could be some type of electric piloting tourism where I could contact you and you could take me up and we can go up to the edge of space? Or is that something that's not have been thought about before?
It's a very good point. We were thinking maybe to do this type of things when we start SolarStratos, but today we saw that it will be very difficult. And also we think that if you can go to space for $200,000 US, you go to space. I don't know if you will accept to pay, I don't know, $50,000 to go to the stratosphere with an electric and solar aircraft. And you know, if you can go with a non-commercial aircraft to the stratosphere just for one explorer, if you want then to go there with a commercial aircraft, it's probably 1,000 times more expensive. So the cost of this project will be huge. And I am more an explorer. I am not a businessman. So I think maybe someone will do it. It will not be me, but why not one day? But now we will see if it's possible to go to the space in, let's say, 10 years for $50,000 US. I think the market of the stratosphere will be dead, you know, because the cost is too high. You know what I mean?
Yeah. I understand that, but not many people have been there. So, and a lot of people have a lot of extra money these days. So who knows? But maybe we should take a look at some of these questions that are building up in the Q&A box. Did you want me to read a couple of these, Heinz?
Sorry, Brian, are you asking me?
Well, I was asking Heinz if we should go through some of the questions that have built up in the Q&A box. Maybe.
Yeah, I'm just scrolling back because there are many, and I think there was one. It was less a question, but it's about using thin film technology on the wings. So not crystalline solar cells, but thin film in order to save weight. I understand. It's not really a question, but probably a request to comment it. Maybe Antonin?
Yes, so for the technology used here, for example, in SolarStratos, so here it's we work with sun power cells, so it's not a thin film. Maybe it was misunderstood about the laminate, which is a thin laminate, but we have high performance sun power cells that go at 210 watts per square meter, so 21% efficiency at the module level.
Then there was another question, I think, regarding the catamaran, asking for the hull speed. I think suggesting the square root of the length of the water length times 1.2. I believe, Raphael, maybe you know this better, but the hull speed, a catamaran is always above hull speed, or am I wrong? Because it's not a displacement boat.
It was a displacement boat, you know.
I see.
The total weight of the boat was a little bit less than 100 tons, and we were using only 20 kilowatts. So we were going quite slow. On PlanetSolar, we were always telling this: slow is beautiful, because sometimes when the weather was bad, we were running at less than 2 knots.
I see.
Yeah. But the average speed of the tour, it was the first. So the goal was not to be really fast. It was a little bit at 5.7 knots. That was the average during this trip around the world. It was quite good, actually.
So you could enjoy the view and.
Yes. Sometimes the view didn't change for many hours, you know.
I've seen you have been walking even on the solar deck whilst navigating.
Yeah, but sun power didn't like when we did this. And even I slept on the solar deck when we crossed the Pacific. You know, the Milky Way was so amazing. You know, it was really amazing. And during the night, of course, not during the day, we put the bed on the top of the boat, and we were sleeping on the solar panel. That was really nice.
The photovoltaic experts really don't like this partial shadowing effects.
There's just a couple of questions that I see here in the Q&A box. We have one that's come in from Ron Leonard. It's very aviation oriented. He says, as a fellow pilot, he's also curious about the stall to Mach speed spread with your project. I don't understand it, but I'm sure you do.
It's talking about the speed, but you know, when you fly on a solar aircraft, the Reynolds number is really high, so we fly very, very slow. This aircraft, SolarStratos, is start to fly at 48 kilometers per hour. The speed, the best we call instrument airspeed is around 70 kilometers per hour. So when we will be very high, the true airspeed, so the real speed will be around 200 kilometers per hour. It's still very slow for this type of flight.
Okay.
So in Mach number, I don't know exactly because I have to make the conversion, but it's below 0.2.
Below 0.2. Okay. Super.
May I relay a question of Stefan Novak?
Yeah, sure.
I think, I don't know whether you've seen it. His question goes also a little bit in our initial questions. Do you see the challenge more on the tech side, allow you to achieve your flight, or more on the side of an airplane flying at such an altitude, or maybe on the side of the pilot who has to live in extreme conditions? I know the flying at this altitude is a difficult of the famous coffin corner.
First of all, I am very happy that Stefan Novak is with us because he's one of the co-founders of PlanetSolar. He was one of our big support during this project with PlanetSolar. And the goal is with SolarStratos, we have many challenges. One, of course, is to find a sponsor. Then it's the technique of the plane. You know, we have to be very light, but more you climb, if you are too light, then you have a flutter problem. So it's the problem. If we are too heavy, then we need more power. Then we cannot go to the stratosphere. And also about the regulation, it's a challenge. The regulation is a big challenge to find someone and to be able that that the regulation will give us the right to do these flights. And then, of course, as a pilot is a challenge because I will fly in a spacesuit. And this is a big challenge because most of the pilots, they have a spacesuit, but the spacesuit is not pressurized because it's the cabin, the plane that has a pressurization. And that will not be the case with SolarStratos. I will fly with the spacesuit and the spacesuit will be pressurized. So this is a challenge as a pilot.
Okay. Stefan was asking also what will be the next steps or what's the progress going?
Next step, we have to go to United States to do the highest ever flight with an electric and solar aircraft to break the record of solar impulse. And the goal is to do this in March, April 2023.
Very good. I have an issue here. Can you still hear me?
Yeah.
Yes.
Okay. I thought we're gone. Brian, you see more questions there?
I do have one more question, and then we're going to probably need to wrap it up. This one's from Max Kempe. He's asking, what is the structure of the panel in aeroplane? Is the weight is 1 kilogram per square meter? Is that?
Yeah, that's very low. So I'm also curious.
Yeah, so maybe it's more for CSEM, this technical question. So yeah, indeed, here we could manage to go at 700 gram per square meter with 21% efficiency. So that is really, we just have developed a special metal interconnection between sun power cells and a specific lamination process with ultra thin front sheet and back sheet, and the mechanical support is the plane wings. So it's no mechanical support inside the PV panel. Yes.
Raphael was mentioning that the plane should not fly in the rain. Has this something to do with this ultra thin front cover?
So for this, yeah, I think on the this is not the final product, so for sure it's not a fully tight, and for sure for more extreme and flying under the rain, we have other solution. For example, we have some structure, for example, for the boats, also lightweight, like more like 2 kilograms per square meter. It's that's hail resistant, so even you can have a strong hail ball hitting, and for sure that here we are targeting so reduced weight that for sure it's is not so strong. Yeah.
Very good, very good. Well, guys, we're kind of at the limit of our 30 minutes. We're actually over our 30 minutes, but I guess Nabi, if you have any other questions that you'd like to shoot in right now before
No,
we go?
I don't have a really other question, but just to say that such projects, as I mentioned, it's extremely important, and the R&D developed around that project to make it successful, and I'm pretty sure that it will be. It's going to be extremely, I would say, beneficial for domestic applications. And for that, I would like to thank the team of Raphael and CSM group and all these things that I know they are doing a very, very great job. Thank you all. And I think that's congratulations in advance.
Thank you. And thank you for all of you. What you are doing is also important. We have to change this world and to stop to burn what we are burning in terms of fossil fuel, 200 tons per second. So, and we have so much energy coming from the sky, and we have to change this, and we have to spread this message about the power of solar energy in the world. So thank you for what you are doing for this challenge and for this goal that we have to we have to do, and we have no times to change now.
Great, great, great. And Raphael, if people have further questions, how can they find you? What's the best way to reach you?
Oh, by mail. By mail is really. Do you have my mail? I think you have my mail, Brian.
I have it, of course, yes. So
Yeah,
if
no
it's okay to
problem.
share it, we could share it with the people that participated in the session today.
No problem. I will try to answer and the one that I cannot, I will send to Otona, because of course the technical side of this project, it's more the CSEM, is not me.
Awesome. Yeah, well, I
Awesome.
really appreciate the time today as well. Look forward to staying in touch, that's for sure. And we'll be doing this again in the next couple of weeks. So we'll be posting this session online very shortly. And then you'll also find other information as far as what will be our next events. And then, of course, we will send you information by email. If we reach you today, we'll be able to reach you again. So thanks, everybody. Appreciate you taking time out of your afternoon. Thank you to the audience. And we'll see you again at our next edition of Coffee Chat. Bye for now.
Thank
Bye-bye.
you.
Thank you. Bye-bye.
Good day.
Thank
Bye-bye.
you.